All right, this is a PreCalculus B, Unit 4, Polar Coordinates and Functions, Lesson 5. We're talking about a group of functions called limicons. And it sounds like limerick, but limicons. Limicons are a whole class of functions in polar coordinates, the polar coordinate system. So let me change the graph display. By the way, changing the graph display to polar coordinates does not change the way that it graphs. You can still graph rectangular coordinate stuff like y equals x squared, still a parabola. Okay, but you can also graph polar functions with r and theta, and the Desmos requires r to be isolated. So it requires, which it doesn't do in rectangular coordinates. It doesn't require us to solve for y. But so limicons are a class of functions that follow this pattern: a plus or minus b sine or cosine theta. Okay, a plus or minus b sine theta. So I've just created sliders for both. A equals 1 and b equals 1, and creates a shape called a cardioid. Cardioid because it looks like a heart, right? And there are several kinds of classifications of cardioids, and it all has to do with the relationship between A and B. Okay, but before we get into A and B, let's see what changing sine to cosine does. Sine, it has it pointing down. Cosine has it pointing left. Change it back to sine, or the spiral. And change the minus to a plus, and now it's pointing up. So positive on the trig function causes it to point in the positive direction. Okay, it's still a cardioid, and cosine theta will cause it to point to the right. Okay, so that's important to recognize. Now in this case, a equals b, right? If I increase a to be 2, or 2, yeah, come on, a equals 2, and, whoops, try that again. A equals 2 and b equals 2. Okay, it's still a cardioid, it's just bigger, right? And it helps if I get that exactly on 2. Notice a couple of things, right? The radius out here to the major axis is 4, right? It's double, it's a plus b. And that literally is what is going on. It's a plus b. Whereas a minus b is 0, and that's the axis here. Now when a grows bigger than b, the whole shape changes. This is what's called a dimpled limicon, right? Because it's inverted. It's got an inverted portion, but it is not a true cardioid. It doesn't come to a point, right? And if I increase a up until the point where it's double b, where it's 4, okay, then we call this, and I'm trying to remember here, a no, don't have it here. There's a name for that, and at the moment it's slipping my mind. Okay, but it turns flat, and if you increase it beyond that point, it becomes what we call a convex limicon. Convex limicon. Yeah, let's see. Inner loop, cardioid, dimpled, convex. I guess it just goes from being concave to convex, or dimpled to convex. There is no official name for when it equals to. So the key here is a, the non-trig function coefficient, the constant, is more than twice as big, more than or equal to twice as big as v, the coefficient of the trig function. Then it is convex, right? And that's greater than or equal to 2. And if it is less than 2, between 1 and 2 times, then it is dimpled. And if it is equal, if they are equal, it is a cardioid. And these are all limicons. And then if it's between 0 and 1, it's called an inner loop limicon. Now I want you to notice a couple of things. First of all, let's increase this to 3. Okay, remember what we said about the sum. 3 plus 2 is 5. Notice its radius is 5. its minor radius, its distance here, is 1, and the difference between 3 and 2 is 1. So the difference gives you the minor radius, and the sum gives you the major radius. The same thing happens in reverse when it's less, right? So if a is 1, 1 and 2 is 3, so the major radius is 3, and the minor radius is 1, difference between 2 and 1. The only difference here is the minor radius is in the same direction as the major radius, and it's an inner loop lemicon. Okay? As it decreases to a point here, 2 plus 0.3 is 2.3, so the major radius is 2.3. The minor radius is 1.7, which is 2 minus 0.3. Okay, so you kind of get an idea of what's going on here. This whole class of functions. Cosine goes right and left, sine goes up and down. If it's plus cosine, it's to the right. If it's minus cosine, it's to the left. If it's plus sine, it's up. If it's minus sine, it's down. And we can trace out some things here. If A equals B, then we have what's called a cardioid. If A is less than B, down to 0, we have an inner loop lemicon. And if A is up between 1 and 2 times B, we have a dimpled lemicon, and if we have A being 2 times B or greater, we have a convex lemicon. Okay? All right, so being able to identify these, graph them, and classify them is the objective of this lesson. All right, hopefully that helps. Play around with Desmos, by the way. I encourage you to do this in Desmos. Desmos is a lot of fun.